Evaluation workshop. We're very honored to have you here, and of course we're very honored to have Professor Alberto Avenue here, where he's going to talk about synthetic control methods to evaluate policy interventions. Before we start, I just want to share a few words about Professor Avenue. He's a professor of public policy here at the Kennedy School, where his main research areas are econometrics, labor economics, and public finance. Professor Abadi has developed econometric methods to evaluate the effects of public programs. Additionally, as a native of the Basque region of Spain, he's long been interested in issues concerning terrorism, and his recent research uses data and economic models to analyze its causes and consequences. He received his PhD from MIT. Aside from being a renowned econometric researcher, Professor Abadi, and I can personally attest to this since I'm in his class, is probably one of the most engaging professors here at the Kennedy School. And I'm not saying this to get a good grade, although if you want to go easy on the next problem, I'm not going to complain. So with that, let's give a big welcome to Professor Abadi.
Thank you so much. Thank you for inviting me here to give this talk, and thank you for coming. I was walking along the river, and I was listening to come. Come to talk about, like comparative case studies, whether it's organized, people were running, biking, the kids were out. Well, it's not working.
Yeah, I mean, it's not. Yeah, we can really do that.
Okay, let me see if there is another one. And there. Okay. I try another one. How about this? Yes. And if not, I will grab one of these microphones. Better now?
Can you guys hear?
You guys hear? No? Not yet? No? Okay, let's try another one, and if not, I will grab one. Just try. Nothing like that. Okay, this one is working. I thought that they have disconnected all of it. This is no? Okay, so I will take this one. I'm going to put it up here. Okay, good. So, one of the nice thing about, like working in the Kennedy School is that, after a while, you are also an expert in audio-visual equipment. So, let's talk a little bit, I want to talk about synthetic controls and comparative case studies and how they can be used to evaluate public interventions. Okay, and that's, you'll see in a second what this is about. So, many times, in many occasions, we want to estimate the effect of policy intervention, and I'm going to be a little bit provocative today. Many of you study statistics or econometrics, something like that, and they always tell you, you should look at them. If possible, you should look at individual, micro, disaggregate data. But what I'm going to say today is that perhaps sometimes macro aggregate data is exactly what you want. And it's exactly what is going to give you the information that that you want. Because in many cases, the policies that we implement are not policies that we implement at the individual level. I mean, we don't know, give, in the medical terminology, a treatment to some individual. Some of the policies or public policy interventions that we can think about, we implemented at some aggregate level, like at the level of a city or a state or a school district or a country. Okay? And when we do that, like every individual and every institution And every organization in this country or in this state or in this city is affected by this policy intervention. Okay? Imagine, for example, this is an example that we will talk about later. Imagine that we are, California, state in the United States, like is implementing some policy intervention. You want to know what is the effect of that policy intervention that happened in California. The whole state is affected by that law or intervention. Okay? You know what happened in California after that law or that intervention was implemented. You would like to know what would have happened without the intervention, and then compare. And once you know what happened with the intervention, and I tell you what would have happened without the intervention, like the comparison between these two things is the effect of the intervention, is the effect of interest that you want to estimate or you want to learn about. Okay? So, how do we do this type of analysis in when we're trying to estimate the effect of public policies? And the outcome of interest is some type of aggregate. Let's think about the example of California again. Like in California, they have this law that is called, like many of you know about this, the three-strike law. Okay, the three-strike law is that if you commit 3 felonies, they basically put you in jail and throw the key away. Okay, and this type of legislation doesn't only exist in California, it exists in many other states in the United States, but basically it's almost only enforced there. Okay? And so you may be interested in what is the effect of this intervention on things like crime, aggravated crime in California. Okay? So that's the outcome of interest that you want. The outcome of interest is some type of aggregate that is crime level, crime at the level of the state. And okay, now it's better? Okay. So now I have two hands. So this too loud. Okay. So the way in which we do this type of analysis, what we usually do when we want to know what is the effect of this type of interventions is to compare what happened in California when they implemented this law with what happens in other states that they did not experience this type of interventions. So this is what is called what we call sometimes comparative case studies. We know what happened in California, we would like to know what would have happened in California in the absence of the interventions. We are going to use other states that were not exposed to this type of interventions to try to reproduce the counterfactual of interest. The counterfactual of interest again is what would have happened in California without intervention. Okay, so we are going to compare the evolution of some aggregate outcome for the unit affected by intervention, in this case California, to the evolution of the same aggregate for some control group, like some other states in the United States that did not apply this law. Okay, so this is what comparative case study is about. Here you have a motivating example that has been used in labor economics. In labor economics, many people are worried about things like the effect of immigration on the labor market opportunities of native workers. Okay, and one of the ideas or one of the analysis that people do is, okay, so this is what we are going to do. We are going to compare, for example, employment rate for native workers in cities where you have a lot of immigration and in cities where you don't have a lot of immigration. But of course, this type of analysis is compounded because immigrants are not distributed at random. Immigrants tend to go to cities where they think that they are going to find employment. Okay, so that's a problem with it, when you try to study this type of questions. And what you would like to have some kind of grand social experiment, where you distribute immigrants at random across cities, and then you will be able to evaluate what is the effect of immigration on the labor market opportunities of native workers. Guess what? We cannot run this experiment. We cannot. There is no way we can do it. So we will try to find some time of quasi-experimental variation in the way in which immigrants go to cities, and see if that is going to work for us. And this is a study that is trying to do exactly that. So as many of you know, in 1980, Fidel Castro decides that whoever wants to leave Cuba can go to Mariel and, live there, and, many people do. In fact, many people do. Many people just go into boats like this and show up in Miami, and in just a few weeks, the labor market force in Miami, I don't know if you ever realized that, but the labor market force in Miami increased by 7%. So it's bam, a huge shock of immigration, sudden, very large. Okay? And labor economists thought that, so here we have the perfect experiment. If it is true that immigration has a very negative effect on the labor market opportunities of native workers, we should see it here. We should see that, as we have this sudden shock, there is also like a large deterioration in the labor outcomes for native workers. So this is what we are going to use. Okay. So this is basically what I was talking about before. We are going to use individual level on unemployment for the current population, this is from a big survey in the United States, and we are going to use this survey to calculate what was the unemployment level for native workers in Miami before and after the married public, and also in a bunch of comparison cities that these investigators choose. They choose Atlanta, LA, Houston, and Tampa. Okay, and this is and this is what they find. So what do I have here? Let's think about only this part. Here we have a table with unemployment rates, and here we have unemployment rates for Miami. We have unemployment rates for the comparison cities, and this is only for white workers, and this is for minority workers, black workers. Okay, and this only native workers in Miami in the comparison cities. So we see that before the boat lift, in 1979, the unemployment rate in Miami for white native workers was 5%. And in fact, it goes down. In 1981, is around 4%. So one could think so there is no effect. But hold on a second, there may be some trends in unemployment and that we are not taking into account here. So we are going to see what happens in other cities. Perhaps it's also true that in other cities, unemployment rate is going down, and it's going down faster than in Miami. But when we look at the comparison cities, we see that unemployment rate in Miami, in the comparison cities before the boat lift was 4.4%. After the boat lift was more or less the same. Okay. So if anything, unemployment rate is behaving better in Miami than in the comparison cities. Okay. This is an example of what econometricians call a difference in difference estimator. They look at the difference in Miami and they compare that difference in Miami between 1981 and 1979 to the same difference in some comparison cities. And the idea is that for Miami, this difference reflects the effect of the boat lift and the effect of temporal trends in unemployment. And for the comparison cities, the difference reflects only temporal trends in unemployment. So when we subtract both of them, we are going to get the effect of the boat lift for Miami. Okay, so the difference estimator here is minus 1 percentage point. If anything, there is a larger decrease in unemployment in Miami and the comparison cities. This thing here in parentheses is the standard error, and I'm not going to bore you with this, but this means that this difference is there. It's 1 percentage point, but it's not statistically significant. But then many people say, well, you're only talking about white workers, but it is possible that the Mariel immigrants affected the labor market opportunities of not white workers but minority workers in Miami. Perhaps they were in in competition for the same type of jobs. So let's see what happens with black workers, and in fact we see that yes, unemployment rate increases between 1979 and 1981. It goes from 8.3% to 9.6%. So it increases by more than 1 percentage point. But if you look at the comparison cities, it increases also, but by more. Okay, it goes from 10.3% to 12.6%. So again, the difference in difference is going to be minus 1 percentage point. you know, the unemployment rate in Miami is increasing less than in the comparison cities. So we don't see much evidence of, you know, like a large effect of immigration on the labor market of population of native workers. So again, the idea of the study is like, if there is a large effect, this is where we should detect it, because there was a sudden, very large shock in immigration in a particular place and a particular point in time. Okay? So this is what, when I was talking about comparative case studies and, you know, aggregate interventions, this is what I was talking about. Here, the authors are using like individual data on employment, because they don't have aggregate data on, you know, the aggregate rate of unemployment for native workers in Miami and in the comparison cities before and after. But, you know, aggregate data will be better. They don't have that data and they are using individual data to try to estimate aggregate data. Okay? So after this example, like, there are some things that we can say about comparative case study. Like, they have several advantages, and one of them is that many of the policy interventions that we can think about take place often at an aggregate level. They affect like entire regions or entire cities, like a state in the United States, you know, a country in Europe. And you know, like, and so like we need some tools to try to evaluate these interventions. And often, like, aggregate or macro data are available even when, you know, disaggregated data are not. Okay, and if it is the other way around, that's not a problem, because we always can aggregate the micro data, right? But you know, we cannot reverse the process. We can aggregate the micro data, but we cannot disaggregate the macro data. So these are like advantages, of this type of studies. But there are like some problems when, two. One is that the selection of control groups of the control group is often ambiguous. Like I told you, and I told you without any comment, that the authors of this study were selecting Atlanta, LA, Tampa, and I don't remember which other one. It was Houston or something like that, as comparison cities. And if you read the paper, if you read the report, it said like, well, they are like, you know, relatively similar cities in the south of the United States. Okay, but there are many cities in the south of the United States. Why you choose these four, or why not three of these four, or why not like you put another five, like there, like or another one there to make it five. So like it is not clear. It is not clear how this control group is chosen, and you know that of course like creates problem, because like you may have two different sets of researchers, like but they have like different ways in which they are choosing the control group of the comparison group, and they may arrive to very different conclusions. Okay, so one of the things that we will try to do today is like try to think about a way to choose a comparison group, a control group that is data driven. Okay. The other thing is that if you think about it, the standard errors, like what in statistical inference we know, like standard errors that are supposed to reflect uncertainty about that we have about the parameter of interest, they are not going to reflect all our uncertainty. This is the idea. Imagine that I have better data that the guys who did this study. Imagine that I have exactly the aggregate unemployment rate for all native workers in Miami and the comparison cities before and after. So I have only four numbers. Okay, I have Miami before, aggregate unemployment rate for native workers. Miami after, aggregate unemployment rate for native workers, and the same for the comparison cities. Okay, I still can calculate my difference in difference estimator, and I should be happier because now I know the sub numbers, I know the aggregate numbers, right? So I can take the difference between, you know, like Miami before and after, comparison cities before and after. I take the difference. Now I have a number, and then what is how do I measure here, you know, like a statistical uncertainty? Well, the classical methods to estimate the standard errors, they are going to tell you that the standard error is 0 because you are observing the entire population. You are observing what is the aggregate, you know, value of the variables that you care about. So you know, like classical statistics tells you there is no uncertainty. You don't have uncertainty, but of course we have uncertainty. I mean, even if you give me these four numbers, the aggregate numbers, I still have uncertainty, because I have uncertainty about to which extent the comparison group is able to reproduce what would have happened in Miami in the absence of the voting. Even if you give me accurate data, even if you give me the exact numbers, I still have that uncertainty. And that's not reflected in our standard errors, in the way in which we usually do like statistical inference. And we're going to see that by fixing the first problem, by fixing the way in which the control group is chosen, we can also fix the second problem. We can create a method that is going to be informative about how much uncertainty we have in the data about the quality of our comparison group, about how well our comparison group may be, reproducing the counterfactual of interest, the unemployment rates in Miami in the absence of the merit voting. Okay. So this is what we're going to do. Let me explain it in words. So the authors of this study, in principle, could have gone to take all the cities in the United States or all the cities in the south of the United States and try to see which combination of cities best reproduces the characteristics of Miami, and use that one instead of using like Atlanta, LA, Houston, and Tampa, St. Petersburg, each of them, because we are 4, and we are taking an average of the 4 of them, so everyone is going to carry a weight. It is going to be like 1 over 4, 1 over 4, 1 over 4, and 1 over 4. So we are doing a weighted average of these 4 cities, right, with the same weights. So like what we are going to do is we're trying to do something similar, but being much more open-minded. Okay? So take all the cities in the United States, or all the cities in the south of the United States. What is the weighted average of these cities that best reproduces Miami? The characteristics of Miami that you care about, the characteristics of Miami that are good predictors of unemployment rate. Okay. Here we're going to do it with a different example, of course, because it's never good to go back to the work of other people and try to prove them wrong. So anyway, so we are going to look at the California Proposition 99. So what was that? So in 1988, California is the first state to pass a comprehensive tobacco control legislation. The first thing that they do, and by the way, this is like a proposition voted in the ballot. So the California legislative, they have to implement. It was a popular mandate that they have to implement. So what they do is they increase cigarette taxes by 25 cents per pack, which doesn't look that much today, but at that point the prices of cigarettes were less than $1 the pack. So it was a huge increase in taxes. But not only that, more importantly, what they are going to do is that they are going to get a lot of money, like more than $100 million per year in the first year, and they are going to get all that money, and all this money is going to be used. Seemingly, my wife is online. All this money is going to be used for anti-tobacco campaigns and anti-smoking media campaigns and so on. Okay. So we know what happened in California. We know what happened in California in terms of smoking. We know how many, packs of cigarettes were sold in California. There are data about this. Even when we don't have data about how many cigarettes people smoke individually, we know how many packs of cigarettes were sold in California in each year. And we know that for the rest of the states. So we will try to, we know what happened with the cigarette smoking in California after the passage of the law. We will try to figure out what would have been, the smoking pattern in California without this law. Okay? And for that, we are going to compare what happened in California to what happens in other states that did not implement this type of tobacco control legislation. So the first thing that we are going to do is we are going to discard some other states that also passed a similar law, in the next few years. Okay? And then we will be left with what we are going to call a donor pool, a set of potential controls of 38 states. Okay? And this is the first figure that I want to show you. This is cigarette consumption in California and in the rest of the US. So the solid line, so this is the year, and this is per capita cigarette sales. Per capita means people who are older than 14, okay? And this solid line is a number of packs sold per capita in California, and the dashed line is the same in the rest of the United States, okay? And I can tell you that many people, I have applied these ideas of difference to this data. So they go here, they say, okay, so this is the difference between California and the rest of the United States at the time of the passage of the Proposition 99, and this is the difference today. So we take the difference in difference, and we are going to say that this is the effect of the law. But this, of course, insane, because even before the passage of the law, California and the rest of the state have different trends. If you take the difference between here and here, you also have like a positive effect, even when there was no any intervention there. Okay? And the problem is that the rest of the states in the United States do a very lousy job reproducing tobacco consumption in California. If you take an average of the other states in the United States, that the pattern of tobacco consumption in those states doesn't look at all like the pattern of tobacco consumption in California. But then the question is there a combination of other states in the United States that reproduces the trend for California and reproduces other characteristics that we think are important to explain this trend? Okay? And the answer is that there is such combination. This is what we are going to call a synthetic control. A synthetic control is a combination, a weighted average of other states that are chosen to reproduce the trend in tobacco consumption in California. Okay, and also they are chosen, to reproduce other characteristics that we think are important to explain this trend. I will show you these characteristics later. Okay, but now we see that there is a combination of other states that looks like California. It looks very much like California, in fact, not only in the level but also in the in the dynamics. Here, both of them go up, and both of them go down, and so on. But after the passage of the Proposition 99, there is a very different behavior between California and this synthetic control. Okay, and this gap we are going to attribute this gap to the passage of the law. Okay, so this is what I call synthetic control. Okay, so how do we build this synthetic control? So here you have a table. Showing, in this table I'm showing you the characteristics that we are using, the characteristics of the state that we are using. We are using log GDP per capita of the states. We are using demographic variables. We are using the retail price of cigarettes and beer consumption per capita. It seems that tobacco consumption and beer consumption are complementary. If you drink a lot of beer, you tend to smoke cigarettes similarly. And we are going to use cigarette sales per capita in 3 time periods before the passage of Proposition 99. Okay, and these are type of the variables that are used in the rest of the literature to try to predict tobacco consumption patterns. So these are the averages of these variables for the real California, for the state that we know as California. And this is the average for the 38 control states that we are using. And as you can see that they are not very similar. I mean, prices were higher in California, the consumption was smaller in California even before the passage of Proposition 99. But then the question is there a combination of these states, perhaps only a few of these states, that can reproduce the characteristics of California before the passage of Proposition 99? And there is, and this is, and this is the characteristics of the synthetic California. It's very easy to see that you get much closer, to the characteristics of the real California relative to what we have for the 38 control states. The state. No, states. We have aggregate level state data. We know, okay, one of the things that we know, we have administrative data on cigarette tax income in California and all the other states in the United States. And because of that, we can know how many packs of cigarettes were sold in California and in the rest of the United States every year. We don't have very good data about, smoking habits at the individual level for many years. But we have very good aggregate data on how many packs of cigarettes were sold in California and the rest of the states in the United States. Okay? So the unit of analysis is the state, which makes sense because this was not an intervention that was done at the individual level. I mean, this was an intervention that was done at the state level. The whole state was affected by this proposition. Okay, not only like some people in this state, not only like some, like stores in this state. Like we have to compare what happened in California to what happened in other states. Okay. So this is this curve that I have here is what we call the gap. That is the difference between the two lines that I presented before. Is the difference between California and the city of California. And you see that by the year 2000, you have a quite large effect of the passage of Proposition 99, like about 27 packs per capita, which is it is quite large. I have to say that and these estimates, by the way, are quite large relative to the previous literature, which is funny because the previous literature was written by tobacco control activists. I don't smoke. I think that tobacco is not very good for you, but I'm not a tobacco control activist. But the things that they thought they were interested themselves in having like an estimated large effect of Proposition 99, but they got like estimates that were much smaller than this. And when you read the reports, you read the papers that they produce, you realize why immediately. And it's because they were comparing California with all the other states in the United States, but also among those in the comparison groups, they were keeping states that later also implemented tobacco control legislation. So the effect in California was looking worse than what it really was. Well, I would say it's surprising because this is like people who have been, some of these people have been like trying to pass this legislation there. So this is what we are going to call the gap for California. And then like those of you who are who like statistics, like the first thing that you are thinking about is like, is this gap? You have estimated the gap. Is this significant or not? Is something that just happened just because of sampling variability, or is something that I should have taken seriously? Is something that is there because your synthetic control is not a good predictor and just doing a lousy predictor of prediction of the trend for California after the passage of Proposition 99. So how can I think about this? So we are going to do some inference, and this is what we are going to do for inference. You cannot. You don't need to look at that. You can look at it. Like, so here is the idea. So I did these calculations for California, and I showed you like minus 27 packs per capita on the year 2000. Okay? Now imagine that I do exactly the same type of calculations for some other state that did not implement a policy like this. Imagine that I do the same type of calculations for Kentucky, and I come out exactly with like something like, yes, I also obtain like minus 28 or minus 30 or minus 18, even when nothing happened there. Then you are going to tell me, well, that I'm not going to take your results about California so seriously, because it seems that like whatever you are doing cannot reproduce the trends of tobacco consumption, even in other states that did not implement this tobacco control legislation. So like this is the way in which I'm going to do inference. I'm going to go on to the 38 states in my donor pool. I'm going to, for each of them, I'm going to find a synthetic control. And I'm going to compare the gap that I calculate for California to the distribution of the gaps for all the synthetic controls or all the states in the donor pool. Make sense? Make sense? Let's have a look at this. So this is what, you remember the gap for California? So this is the gap for California. And all these lines here are gaps, for all the other like 38 states. And this is of course we fit the states much better before the passage of Proposition 99 than after the passage of Proposition 99, because this is like within sample prediction and this is out of sample prediction, right? But one of the things that you can see is that the effect that we observe for California, or that we estimate for California, in fact, is quite extreme and relative to what we estimate for the other states. Okay, some of them can have like extreme positive. Some of them, in fact, because they are using California as a comparison. Okay, but in fact, this is not even a fair comparison because look, we have states here, here, and here, and here that we are not even able to reproduce the pattern of tobacco consumption even before the passage of Proposition 99. Okay? You look at the data and you realize that no one smokes more than those guys there in Kentucky. Okay? And it's not possible to reproduce tobacco consumption patterns in Kentucky using a combination of other states in the United States. They smoke too much. Okay? So these people here, the people who are at the streams, we cannot reproduce. Okay? So what we are going to do is like we are going to iteratively, like get rid of people that we cannot reproduce very well, before the passage of Proposition 99. Because if I have shown you the result that I have a huge gap for California after the passage of Proposition 99, but in fact I have a huge gap also before the passage of Proposition 99, you wouldn't have taken my result seriously. Right? It's like, yes, you tell me that you have a gap after, but you also have a gap before. So we're going to take out of the picture the ones that have like a large gap, also like before the passage of Proposition 99. We can do it like a little bit sequentially, taking the worst first. You go like this, like this, like this. Okay. Like now we have in this picture we have only the ones that we can predict. The tobacco consumption before the passage of Proposition 99, almost as well as California. And you can see that California is quite an extreme observation, among all these. Like all the gaps that we estimate for the rest of the states, are not as large as the gap that we estimate for California. Okay. Another way to look at this is the following. Here we have something that technically is called a ratio post-Proposition 99 mean square prediction error to pre-Proposition 99 mean square prediction error. So what is this about? So we are going to calculate a ratio, and in the numerator is going to be how large is the gap after the passage of Proposition 99, and in the denominator is going to be how large was the gap before the passage of Proposition 99. And we are going to keep all the states. And you can see that California is quite extreme. That is the gap for California after the passage of Proposition 99 is 103 times the gap for California before the passage of Proposition 99. Okay, so we can predict California very well before the passage, but very badly after the passage. And we say that we cannot do that because of the effect of the law. Okay, because of the effect of Proposition 99. Okay, so like this is like the variables basically. So we decided that since we are not a huge experts in tobacco consumption, this is what we will do. We will follow what the experts say. So we will look when we went to the literature and we use exactly the same variables that other people are using in other, using regression analysis and so on. One of the funny things is that even when you have all these variables, you still have to figure out how much you are going to weight each variable, because perhaps you want to fit these ones very well and this one not so well, and that depends on what is the predicted power of that variable on tobacco consumption. And we have a way to look at that. That is data driven, that kind of the computer think about which variables are more important, which variables are less important, and the ones that are very important we will try to fit very well. When we did this the first time, I don't know if you realize this, but in terms of log GDP per capita, we don't gain anything. The log GDP per capita for the synthetic control and for the average of the other 38 states is exactly the same. And we were a little bit puzzled about this and why we are not gaining anything. And the reason is that when you look at the data and you look at what the computer is doing, is because once you fit, you can show that once you fit these other variables, log GDP per capita does not explain tobacco consumption. So the algorithm is not doing any effort to fit fit it. Okay, so what time is it? So we have until 5 something. Okay, so let's have a look at another application. Like many people around here, and many people in the evaluation community have like a great aversion to what is called cross-country regression. Like it's doing like a data analysis, like comparing, and the regression analysis comparing characteristics of many different countries. And this was reflected in a comment by Arnold Harper, who said, what do Thailand, the Dominican Republic, Zimbabwe, Greece, and Bolivia have in common that made their being put in the same regression analysis? Answer: for most purposes, nothing at all. So like you just say, like, yes, you're doing a statistical analysis, but you're putting like Luxembourg and Uganda in the same basket, and these two types of countries really you cannot compare. Okay, you're doing too much of extrapolation here. And so if this is the case, you can think like perhaps you can use some of these ideas, these ideas of synthetic control to to compare countries that are comparable. And these are going to be a data-driven procedure, which is going to tell you which countries you can use as a comparison. Okay, and this is an application because I guess that we were sufficiently ambitious that day when we decided to look at the economic impact of the German reunification in West Germany. This is like an issue of the great debate in West Germany, to which extent people in West Germany paid in terms of economic well-being for the reunification. Okay, and we are not going to compare West Germany to countries that are very different. In fact, we are going to restrict our pool not to all OECD countries, but only a sample of them that are quite rich. Okay, so this is what we are going to do, and this is what we have. This is the variable that we are going to use. Also, like answering the previous question, these are variables that are used in the economic growth literature to try to explain which that they are thought as they are the determinants of economic growth, like GDP per capita today, inflation rate, trade openness, human capital investment rate, and sectoral share. And we have data for West Germany, and we have data for the rest of the OECD sample, and here is for the data for the synthetic West Germany. This is the data for the combination of other countries in the OECD sample that best resembles what happened in West Germany before the German reunification. You can see that we are successful, like reproducing some variables like investment rates. We are not successful in reproducing other variables like inflation rate, because no one was better at controlling inflation than those Germans. Okay, and like the best that you can get is like a 5.17. And you could get more by extrapolation, but would be my mere extrapolation. This is what this is as far as the data can go. Okay, so but this is what we're able to obtain. Let's see if this is good enough. So this is what we have. This is the solid line is West Germany, the dashed line is the synthetic West Germany, and I remind you that the German reunification was in 1990. Okay. And so like you can see that the two lines follow close each other, and then like there is a gap after reunification, and we are going to attribute this gap to the effect of the German reunification. Okay, so that's an example of the application of the synthetic control to data that you obtain at the country level. And again, this is country level data. We have like all the data we have with GDP per capita at the country level, inflation rate at the country level. We don't have there is no individual data. Okay, and this is like what we obtain in terms of a gap. And these are, by the way, like here I have the country weight. So like which is the synthetic control for West Germany? Well, it's not that surprising what we obtain. These are all the countries that we have in the donor pool. And what we obtain is that Austria plays a big role, not very surprisingly. Like the Netherlands plays a big role, Switzerland plays a big role, and also Japan and the United States. Okay, and the rest of the country have zero weight. This is the combination of countries that best resembles the the economic characteristics of West Germany before the German reunification? There was a question.
How did you decide how much to wait for different countries?
Sorry, say again?
How did you decide how much to wait each country?
The weights are chosen such that the resulting combination is the one that best resembles the characteristics of West Germany before the reunification. So this is data-driven. You have the variable, you have the countries, and then there is one solution. That is, there is one combination of countries that best resembles West Germany. And that's what you use. I didn't choose the weights, the data did. And that's what allows me to do the inference that I was telling you about. Because now that this is data-driven, I can do it for every country in the control group, and I can see my gap is large or small relative to the gap that I obtained for countries where this didn't happen. There was another question. There, I'll go there. Could you talk a little louder because I...
Yeah, sorry, this is just kind of related to that question, but how do you practically do that? Is there...
If we have 1 minute, I will show you. Because we wrote code for this, and I have it in my computer, and I mean to show you. We have a few minutes how to use it.
What does industry share refer to?
Well, of all the value added in the economy, how much was created in the industrial sector? You have services, you have agriculture, you have other things.
You chose those countries.
Yes, the donor pool is chosen.
You thought they might be useful as part of the.
Say again?
You chose those
Yes.
countries so because you thought they might be.
Because we thought that these are countries that we will feel comfortable if they were to use as a comparison for West Germany. We started with OECD countries. We discarded some countries. For example, we discarded Mexico because we think that it is a country that has a structural, economic, characteristics that are quite different than the ones of West Germany. Okay, and this is your choice as the investigator. Is your choice as also a design choice. But once you make a decision on the countries and once you make a decision on the variables,
Yes.
there you go. So this is not decision free, but I think that it's making, it's asking you to make the decisions on things that, you are much better on the computer. That is which countries you think would be good comparison and which variable we should take into account. And once you have made that decision, the computer does the rest because it's better than me, perhaps you, but for sure me, calculating the best combination. Okay, so now we know that many of you may be thinking, now you are going to show us that, if you applied, the synthetic control to these other countries, and you are going to show me the distribution of the placebo, the placebo gaps for all these other countries, and you are going to tell me that, that the gap was bigger for West Germany and so on. I could do that, the result is very similar to the one as in proposition 99. But I'm not going to show you that. Why? Because every time that I do it, I have a question from the audience that is telling me, but well, hold on a second. You're telling me that now we are applying the same method, not to West Germany, but to France. And the idea is that somehow there was a reunification in France, but France is having a reunification with whom? If you don't like that idea, I have another way to do the inference for you. That is the following. Instead of thinking that, having the thought experiment, what would be the gap that we estimate if we apply the synthetic control to a different country, you can think what would be the gap that we estimate if we apply the synthetic control to West Germany, but in a year where there's one, in a year different from 1990. So what happened if you you go to your computer, but you're having a bad day, you forgot that the reunification was in 1990, and you put there that you say that the reunification was in 1980. You were wrong. I mean, you're having a bad day. The reunification was in 1990. But you hope that if you make that kind of mistake, the computer is going to tell you that there was no effect. Okay, there was no effect of reunifications that never happened. Otherwise, you would think that the effect that you estimated for 1990 is it's not that. It's not that credible. So we did that. So what we did is we did a placebo reunification. We took West Germany and we say what happens if we fool ourselves and recoding the data that the planification was not in 1990, was in 1980, and estimate the synthetic control, and hopefully we're not going to find a gap. And it's exactly what we do. We don't find a gap. When there is no planification, we don't see an effect, and that gives us some confidence that the synthetic control is doing a good job reproducing the counterfactual of interest is that the trajectory in GDP per capita when nothing happens. We know what happened. We know what happened to GDP per capita in West Germany with the planification. We want to know what would have happened without the planification. Okay. And this basically concludes my presentation. I can take questions. I can also show you a little piece of software that we have to calculate this. Okay, whatever. This is like customer base, whatever you guys want. Okay, software. Okay. Let me see. Okay. Hopefully it works. I did it in class lately, not recently, I should say. But let's hope that it's going to work. Let me see how. Okay, like this. Okay, so this is a statistical routine that we wrote in Stata. Stata is Stata is a very. I don't have equity in Stata or anything like that. No relationship, but it's a very popular. It's a very popular software for. Okay. I think I don't see the programs that I was going to show you, but there must be behind this. There you go. So it's a very popular software to do statistical analysis. And what do I have here? I have this DTA file here. This is say smoking is the data for the smoking example. This Germany DTA file is the data for the West German planification example. And these examples too is the program that I run in order to do this type of calculation. And so let me see how let's just run this. Okay, so this is stopping here. Stata has this thing that you can ask Stata to stop from time to time, so that you can think, because Stata is thinking very fast and you're not thinking so fast. And I asked Stata to stop to show you what how you can do it. So the name of this command is called synth. It's obviously for synthetic control. And so you write synth, and then you write what is going to be your dependent variable of interest, your outcome of interest, that in this case is like a sale, that is cigarette per capita sales in the States. And here, after that, you put the names of the variables that are going to be your predictors. This beer is beer consumption, this is log income, this retail price of cigarettes, demographics and so on. Okay? And you say that, you put a comma here, you see that the treated unit is unit 3, that is like California. You see that the treatment period is 1989, that is the first time that you have proposition 99. And this is other stuff that you don't need to know now. And this peak here is saying the program that please, once you do all this calculation, give me a nice figure with, the synthetic control, so I can have a look at it. Okay. And by the way, at some point we talk about that. We have all these variables, and we have to think which variables are more important. So sometimes you may think, okay, of all these variables, the first 3 I want to fit very well, and the last 3 I don't want to fit so well. And there are different ways to do that. The first way is just running a bunch of rotations very, very fast and do something dirty and fast, but tells you what is the predictive power of all these variables. That's fast, but it's not as good. There is a second alternative that takes longer time. It's like a nested optimization model that tells you which variables are better to predict the outcome. So in the first run is going to be with a quick and easy way to decide which variables are more important. And here you get getting you the weights in the synthetic control for the states. Here is giving you the characteristics for the the state of interest here, that is like California is the treated state and then the synthetic, and what else? And here is giving you a figure. Okay? And you see that this figure looks okay, but doesn't look as good as the one that I showed to you. And it's because we are doing it quick and dirty. I mean, we're calculating the importance of these variables in the fastest way. But let's try to be a little bit more careful and just say like, okay, so I'm going to go with the here it says like nested optimization routine. It is the way in which the computer takes a while thinking which variables are more important to predict the outcomes and which variables are not so important. And you will see that it takes a little bit longer. So now it says like a starting nested optimization model. There you go. Okay. The next thing, okay, so it finished. So it's not too bad. It's not too bad. It gives you the weights for the states, the characteristics of California and the synthetic California, and it gives you the figure that I showed you in the presentation. So what the computer is doing here is trying to think which variables are the variables that are important to predict the outcome. Gives a lot of like try to fit these variables very well, and calculate the combination of states that is best reproducing the characteristics of California before the passage of Proposition 99, and then like giving you a figure like this. And like the rest of the file is the same things, but for the West Germany and so on. I don't know if you guys want to see that. It's very, very, very similar. Okay, so like here I think I have what do I have? I have the placebo. No, this is for this is the estimation of the effect for West Germany, also using regression analysis to estimate it to see the weights for each variable, and then like we try to do it a little bit better using the nested optimization procedure is going to give you something with a better fit in the pre-unification period. So there you go. And now it becomes like now gives you what is the effect of the German unification in a year that the German unification did not exist. Okay. Anyway, so that's it. So questions or
I have a very naive question, maybe you don't even need to get. What is the difference between the synthetic California or the synthetic West Germany and the average of the aggregate of the comparator countries and comparator states? What is the difference between the synthetic and the average of those comparator, the aggregates of the comparator?
yes, like we saw part of this. Let me see. Okay, so this is California and the average of all the 38 states. The rest of the United States, the rest of the United States samples. So you can see that yes, there is a large gap after the passage, but there is a large gap before the passage too. So here you cannot really disentangle what is the effect of a Proposition 99. That is the motivation of trying to obtain not a combination of all the rest of the states with equal weights, but a combination of the combination of states with such weights that the characteristics of California is best reproduced before the passage.
That's the magic wand that causes them to be less.
Yeah, and this is the average.
So, but it does take that judgment.
Which I mean.
Determining what are the characteristics
Oh,
of
yeah.
California and why you weight the other ones. So then, when you after weighting them, you're going to get the line to.
There are two judgments here. There are two judgments. One is like which are the potential comparisons, which comparisons you may want to make.
That's why you take the states that didn't have a problem.
Yeah, exactly. You don't want to throw their states that also pass the Proposition 99 because then you are going to have like some attenuation in your estimation because these guys also are having an effect. Or you don't want to compare. You may not want to compare West Germany with countries in,
So it's
with
the
different-
plus the weight.
yeah. That, no, not the weights, not the weight. That and the variables that you're going to use.
And the variable.
That you're going to use. Then once you have made this decision, the game is like which combination of states best reproduces these variables. Okay, so among the states that you told me, among the states that are kosher, which combination of those is the best in reproducing the characteristic of California that you gave me?
Now I get it.
Okay.
Apologies if
No.
everybody else.
No. Let me start here and then I will go there. I will travel.
So if we wanted to use this method, these methods, do you have like the do file and some examples?
My webpage.
Your webpage.
And you have at least one of these data sets for you to play with.
My question is how widely used is this technique?
How?
How widely used is this technique?
How will I use? We came up with this like a few years ago. Like the first application of the synthetic control method is in a paper in 2003. But then there was no theory and there was no code or anything like that. We have like code available since a few years ago, and from what I don't know, I can give you like a number, but from what I saw there must be like around 100 applications, 150 applications. I see.
What are the main downsides to this technique?
What is the main down?
Law.
Well, sorry?
The ARMA?
No. The thing is that if the dynamics of the variable that you're trying to explain is very, very complicated, even if you're able to fit those dynamics before the passage of the intervention that you're interested about, that may not be very informative about what happened after that. So that's a concern. But at the same time, it's a concern that you can test to some extent, because you can do like that we did. So let's go here. You can look at this and you can say, okay, so this thing maybe perhaps the effect of German ramification, maybe perhaps that your method is very lousy, trying to, like predict GDP per capita. Okay? But then, you feel a little bit more confidence when you see this figure, right? Because then, like, you see that, when nothing happens, you are able to reproduce GDP per capita. So if you give me like series, like a variable that has like a wild behavior, like it's maybe very difficult for this method to reproduce that, or for any other method, but for this in particular, because this is based on the, if you want, on the idea that to some extent, like if you, that the states that behave similarly in the past will have behaved similarly in the future in the absence of the intervention. That those two types of states are, affected by the same trends.
This synthetic West Germany, is it the same set of states as the other synthetic West Germany? Because
No.
okay.
No. Otherwise it would be too easy, right? No. What we did is we went to we really proceed. The idea is to proceed exactly as if you suddenly believe that the reunification was in 1980. So you do what you have done for 1990, but using only the 1980 data. So you are going to try to fit only the 1980 data, and then see if you observe a gap or not. Like what you're telling me, if you have used the same weights, well, you already saw us that they was very well fit here. So I'm not going to be very surprised if you are telling me that it was very well fit there. But they are not the same weights. We are doing exactly the same as we did before, but for 1980.
So there was a report, I can't remember who the authors were, but it's rather recent, on Millennium Villages Project.
Sorry, again?
Millennium Villages Project,
Mhm.
and they got really heavily criticized.
Mhm.
And it seemed really similar to
So like the criticism applies by.
They use what seems to be like this.
Okay.
But it was at a household level, they took a bunch of attributes and retroactively applied them to members of the community, so found out that income is not increasing, so money levels are. So I just wanted to know if you're familiar with that. That sounds similar to what you're doing.
I am superficially familiar with that, not enough to make an informed comment.
Well, the confusing part of it to me was, again, retroactively applying attributes to household level. Like, there was enough survey for folks to do the study.
So like people who saying like, what was my income like 5 years ago or something like that. Well, there are like a lot of problems with this type of data, like you know, like people tend not to remember that well. You know, like these type of things. Here, I mean, like the data that we are using is, you know, it's not relative. It's like GDP per capita, inflation rate, like these are really data, you know, and usually we have very good information about that. Like perhaps GDP per capita is not reflecting what you want to reflect, but it's measuring very well what it wants, what it's measuring. And the same with inflation rate, trade openings, and so on. And again, with the smoking example, it is difficult to have data, individual data on smoking consumption, but it's very easy to have aggregate data on tobacco consumption at the state level, and those we know for sure.
There's any examples of this applied to environmental
Yes.
conservation rather than
Yes. Yes. This is from a recent session on synthetic controls in the American Economic Association meetings, and there was one example about this. And I apologize for using the slides of these guys. So, but this is what they presented. They, this is the effect of emission targets, and they were doing it. They were using the controls for many countries. Here you have Australia, France, Germany, Great Britain, and in fact they only found that, and they found basically that the only country for which this emission controls is working quite well is the UK. But much more than I know about this. But here you have the title of the study and the authors.
Okay, let's give.
Thank you so much. Thank you.
He said if anybody wants to talk with him, we'll stay for a few minutes. So
Invite me over here.
which of you will have to later? So next at 5:30 we're going to have our closing keynote.